A ball is thrown upwards with velocity 20 meter per second from the top of a tower having a height of 50 meter. What time elapsed when it again passes the edge of the tower? Okay. So let me just draw a diagram first and then we'll look for the solution. So this is the tower. The body is projected from here. It will go to the highest point. It will come back to the same position, and then the body will drop and reach the ground. Now let me mark this point as A, this as C. Now what we should understand is, though I have drawn the points A and C separately, while we consider the linear motion, it happens like this. The body is projected from A, it reaches B, and then it comes back and eventually reaches A. Or to make the concept more clear, AB is the ascent, right? AB is the ascent. I'm sorry, AB is the ascent, whereas BC is the descent. So for the entire motion, for the motion of the body in the direction AC, right, or the motion along the direction AC, what is displacement equal to? Say displacement is the difference between the final and the initial position. Initial and final position are the same, which means the displacement is 0. Now what is the displacement time relation? S is equal to ut plus half at square. And what is u? The body is projected upwards, so the direction of u is upwards. Acceleration due to gravity is acting downwards, so if we take u as positive, acceleration due to gravity would be negative. Displacement is 0. So initial velocity is given as 20 meter per second, so we have 20 meter per second into t plus half. A is minus 10 into t square. So if you bring this term to the LHS, what do we get? 10 by 2 is 5, so we get 5t square is equal to 20t, and therefore t is equal to 4 seconds. So the correct option would be option B, 4 seconds. Now if you want, we can have a detailed description for the motion, also for the individual motions also. Let's see if some of the students may ask for such a explanation also, so we can see that part too. So let me call this portion as B, right? So basically the time taken to cover AC would be equal to time taken to cover AB plus time taken to cover BC. Now along AB, the initial velocity u is 20 meter per second. The final velocity v is equal to 0. So here, if I write the first equation of motion, we have v is equal to u plus at, in which case v is 0, u is 20, and a is minus g, because acceleration due to gravity is acting downwards, into t, right? So if it transpose minus gt, then you get gt is equal to 20, and therefore t is equal to 2. So time of ascent is 2, right? So time of ascent is 2, which will be equal to the time of descent, and therefore the answer would be time of ascent plus time of descent, which is basically 2 plus 2 equal to 4. Now some students may want to go even further and to find it analytically the time required to travel BC. We'll do that also. See, for the travel BC, the initial velocity u is equal to 0. Final velocity v would be the same as velocity at A, which is 20 meter per second. This time the body is coming, the velocity is acting downwards, acceleration due to gravity is acting downwards, so we'll take both of them to be plus. So v is equal to u plus at. So u is 0, v is 20, so we have 20 is equal to 0 plus 10 into t. So what is t again here? 20 by 10, which is 2. So time for BC is also 2. Now if you add, so time for AB is 2 and time for BC is 2. So therefore time for AC will be equal to time for AB plus time for BC. Time for AC will be equal to AB plus BC, which will be equal to 2 plus 2 and therefore equal to 4. So I have found out the solution in 3 different ways. You can follow either. Well, this is just to make sure that to let you know that you can solve one question in any format and then came at the same conclusion. But you should always keep in mind that the sign convention will determine whether the answer is going to be correct or not.